In this video, you're going to learn how to make a box plot. The data we're going to use are a set of scores of 14 fourth grade girls on an agility test. The score represents the number of times that the girls can jump from side to side across a set of parallel lines in 30 seconds. The first step to making a box plot is to list the numbers in order from smallest to largest. So pause your video and write those numbers in order from smallest. The next step is to divide the data into fourths. First we'll divide it in half. Half of the data is 22 and below, and half the data is 24 and above. If there were a middle number in the set of data, if there were an odd number of data values, that middle number would be what's called the median. Since we have an even number of values, we will average those two numbers together, which is 23, and that will be the median. Then we look to the left of the median and we see 7 data values. Picking the middle data value, 20, that data value is the boundary line for the first quarter of the data. So we're going to call it quartile 1 or Q1. Looking to the right of the median, we'll once again pick the middle number in order, and we'll call this Q3 or the third quartile because it cuts off 3/4 of the data. The last two important numbers are 12 and 28, which are the minimum and the maximum values. So we have what's known as the 5-number summary. The minimum, the first quartile, the median, which is also quartile 2, but we call it the median, the third quartile, and the maximum. With those numbers now we're ready to draw our box plot. So in order to draw a box plot, we need a scale. So I would like you once again to pause your video and to draw a scale from 12 to 28 on a number line. And leave a little space above it, obviously, for the box plot. Okay, now that we have our scale, we're ready to draw the box plot. We start out looking at Q1 and Q3. And we're going to draw a line, a vertical bar, at Q1 and at Q3. And we're going to draw a box, a rectangle, to represent the middle 50% of the data. And then we're going to draw a line representing the median. So these three values, Q1 and the median and Q3, are represented by this middle box. I'm going to pause for a moment and let my video catch up with my words here. Okay, we're all caught up now. You may have heard this graph called a box and whisker plot because there's a box in the middle and there's kind of some lines that stick out to the side. Now we need to draw the little parts that stick out from the sides of the box plot, which are often called the whiskers. You may have heard this plot called a box and whisker plot. We're just going to call it a box plot, but I'm still going to refer to those things as whiskers. So we're going to draw a whisker out from the side of the box to the maximum value. So there's our maximum point. Now, when we have a point, though, that's as far away as 12, we want to check. We want to make sure that 12 is not an outlier. So I'm going to show you how to figure out what an outlier is. And the first thing we need to know is a number called the IQR. And I'm going to write this on another page, but I just want to have you look for a minute at your box plot. The difference between Q3 and Q1 is called the interquartile range, or the IQR, and that difference is 5. So we have the IQR is equal to Q3 minus Q1, which in this case is 25 minus 20, and that equals 5. Now, to determine whether something is an outlier, we have a rule of thumb called the fence rule. And the fence rule says that we can take that interquartile range as kind of a measuring stick, and we can multiply it by 1.5, which in this case would be 7.5. And we can add 7.5 to each end of the box, or actually add it to the top end of the box, subtract it from the bottom end of the box, to figure out where those kind of imaginary fences are, outside of which would be any outliers. So the lower fence would be Q1 minus 1.5 times the IQR, which in this case would be 20 minus 1.5 times 5. 1.5 times 5 is 7.5. 20 minus 7.5 is 12.5. The upper fence is the IQR, is the Q3, I'm sorry, minus 1.5 times the IQR, 5, and that would be 25 plus 7.5, which would be 32.5. So since we don't have any values as high as 32.5, obviously 28 is not too high. It's within the upper fence. But 12 is a little bit lower than the lower fence. So that means 12 is an outlier. Now I will tell you that if I had a value of 13 and a value of 12 in my data, I might not consider 12 an outlier because it's so close to the fence. I could make a judgment call and say, well, that's not really far enough away from the rest of the data to be an outlier. But since there's a fairly good sized gap between 12 and 16, the next lowest value, we're going to consider 12 an outlier, and it falls below the fence in the fence rule, so that confirms our judgment. So we mark an outlier with an asterisk, and then we extend the whisker out to the next lowest value, which is 16 in this case. Now 12 is still considered the minimum value, even though it's an outlier, but it's just drawn differently. So what we have here now is a box plot, and I did forget one important thing, and that is I need to label my scale with context, because you know whenever you draw a graph you need to include context. So I'm going to label my graph agility scores, and this doesn't have any typical units, so I'm going to make my units here number of jumps per 30 seconds. So I have my label, my scale, my units, and I have all of my values shown. Often it's typical to write the numbers 12, 20, 23, 25, and 28 above the graph, but if you have a clearly labeled scale, that's not necessary. Now, what does a box plot show you that maybe another graph doesn't? It shows you the division of the data. It shows you the percents. It divides the data into fourths. So I'm going to use some red here to have a different color. 25% of the data is between 12 jumps and 20 jumps. 25% of the data is between 20 jumps and 23 jumps. Another 25% of the data is between 23 jumps and 25 jumps, and the upper 25% of the data is between 25 jumps and 28 jumps. So we can look at this box plot and we can look at the context of the data, and we can say things like 75% of these girls jump between 20 and 28 jumps in 30 seconds, while only 25% of the girls jumped 20 jumps or below. We can say that the 25 lowest data values have the same spread, a spread of 8, as the upper 75%. So we clearly have a skew to the left here because we have that longer tail to the left. We can say what the middle jump, we can say half the girls jumped more than 23 jumps in 30 seconds and half the girls jumped less than 23 jumps in 30 seconds. So we have a lot of things that we can say using percentages. Now this data doesn't, just by looking at the box plot, we can't tell that we have repeated values. We can't tell that there's a cluster of jumps at 25, for example. All we know that is that we have a group of 25. So for example, I guess I want to stay with red here. We just know here's one quarter of the data, here's another quarter of the data, here's another quarter, and here's another. And different quarters of the data are more spread out than others. But there's 1/4 of the data values in each of those sections of the box plot. So that is how to make a box plot. Hope you enjoyed the show.